Number 2. And that is the best half of a parabola I've ever drawn.
That is incredibly good.
The right side was not so good. I erased the right side. Okay. I'm staying with that. So, guys, kind of an interesting question. I attempted to sketch the graph up there. If we're looking for the area, the total area bounded by those graphs on that interval, wouldn't this, oops, that's way too much. Wouldn't this in here be at least part of it?
Wait.
Isn't it negative 4?
Oh, is it negative 4?
Yeah.
So, there we go. How about, well, let's see here. Negative 4 to 0. Wouldn't that guarantee this then?
Yeah.
Okay. But then the question is, what is this intersection point out there, right? That'll help us determine a few things, right? So how would we find that intersection point? You could graph it, or you could probably do it faster by just setting them equal to each other. So it'd be 0 equals x squared plus x minus 2. 0 equals x plus 2, x minus 1. And interestingly enough, you get these two intersection points, negative 2 and 1. This over here is obviously the 1. I don't really care too much about that. That's not on our interval. But the negative 2 is in the middle of our interval, right? So if you think about it, if this is negative 2, negative 4 would be over here on the edge somewhere, wouldn't it? And I would need to take, well, I'm sorry, I'm going to have to do this. I'm going to have to take the more lovely side of my parabola and try not to mess it up. Oops.
Oh, no.
It's not worth it. It's not worth it. We can just imagine your life.
It's not as good, I know. I'm sorry. I tried. You know, it's like someone going to the Mona Lisa and trying to like just tweak her smile a little bit or something. You know, you're going to mess it up no matter what you do, right? Okay. So we're really talking about these two different areas, aren't we? Two different areas. So when you start thinking about representative rectangles and all that stuff, here would be a representative rectangle for this one. And then over here, maybe we'd have a different looking representative rectangle. I'll make it orange, like this. And so I've really got to find these two separate areas and add them up, right? The reason being is for the area with the orange rectangle, the line is the higher function. But for the area with the yellow representative rectangle, the parabola is the higher function, right? And so I'd set it up something along these lines. Bless you. I would say area, like the total area, equals, it'd be the integral from negative 4 to negative 2. That's going to be the area with the orange representative rectangle. And it's going to be line minus parabola. So it'd be x minus quantity of 2 minus x squared dx. So that should, if calculated correctly, should give us the area of the left region. And then I need to add to that the area of the right region. That would be from negative 2 to 0. But then now the relationship between the upper and lower part of the representative rectangle would be reversed. So it would be now parabola minus line times dx. You would then either use Math 9 or you would find antiderivatives in FTC 1, depending on if the calculator was active or not. And those of you that are AB veterans from last year, you know that every now and then they'll give you something like this, and you got to take it all the way through on paper and pencil, right? Sometimes Math 9 would be the deal here. I'm assuming, because you're all mature people, that you picked the thing that you needed to work on. If they were both easy for you, I bet you picked the one that was quicker, right? I can respect that. Wondering if anybody did take this one all the way through to a finish line. Johnny, did you get one? What'd you get?
12.
Say one more time.
Yeah, 12 is the total answer.
12 for a total area there?
Yeah.
Anybody confirm that? You can confirm that? Okay, awesome. Okay, so the word in here that I think is key, I think if you ever see the word total area, like that term total area, I think immediately there should be like a little bit of a warning going on in your mind that says, oh no, I bet you the high-low relationship gets flipped somewhere. Like if you see the word total area, they're trying to tell you there's going to be multiple areas that you're going to have to add up, and the whole high-low thing will be flipped at least once somewhere in there. Okay, questions, concerns, comments? What can I do to help if there's anything that needs helping? Okay, fair enough. Thank you. So let's take a look at number 3. I think we only have 2 more. Yeah. All right, so number 3, this sometimes is a challenge. So I put a little note here. Sometimes it's easier to use a horizontal instead of a vertical representative rectangle. And this is where people sometimes will get really out of their comfort zone because they're like, everything's always been in terms of X. And it's always been a vertical representative rectangle. I totally get why that's your comfort zone because we do that a lot. But the truth is, if you understand that an integral, a definite integral, is simply an accumulation, an infinite accumulation of really skinny things, it doesn't matter if the skinny things are vertical or they're horizontal, right? You're still accumulating either from bottom to top or left to right, but you're still accumulating over an interval. So when we do this, the representative rectangle is no longer dx thick or dx wide. It is dy wide. And this little differential, the thing that doesn't seem to matter that much, actually very much matters, because once you decide it's going to be a dy thick representative rectangle, that means everything in your integral has to be in terms of y. Everything would have to be in terms of y in a case like that. And there are going to be some times when this is, like I said, the better method. There are going to be times when this is not the better method. And we'll talk about maybe those scenarios, why that would be. And I think we'll talk about that a little bit on this one. So let's take a minute and graph these. And then I'll let you kind of, either do some remembering about how to do this or some thinking about how to do this. So let's do this first. If I remember right, my DC folks did some of these graphs where X was in terms of Y, but I think regular pre-calc classes do not. I could be remembering wrong, and frankly, I don't remember who did what. So let's just talk this through. The first one, can anybody describe what that X equals 3 minus Y squared? Just a general idea of what the graph looks like?
Sideways parabola.
Sideways parabola, and you said left opening. What about the 3? Shifted right 3. That's correct. Okay, so that, oh boy, here we go. Another parabola opportunity.
No pressure.
No pressure.
Well, that's pretty good. I don't know about that one. It's like a little shaky.
Oh!
Oh no.
Get that steady.
That's really close. That's not bad. It was okay till the end, wasn't it?
Yeah, that was one more.
It was pretty good until the very end.
Never mind.
I'm staying with that one. I'm staying there. That's definitely has its flaws, but it's not too bad. Whatever. The things we do to entertain ourselves. Okay, so you guys described that really well. What about that X equals Y plus 1? This would be a pretty easy one just to like transform into the normal, right? I don't know. What's the X-intercept on that one?
-1.
X-intercept is actually positive 1, right? When y is 0, x is 1. So x-intercept here, what's the slope? I think it's positive 1. You guys ready for the straightest line you ever saw?
Ready.
Yeah. Totally got you.
That's cheating.
It's totally cheating. I used the line tool. Yeah. It's a straight line, though. You got to admit. Okay. So let me. I'll tell you what. You know what? I'll just let you kind of mess around with this a little bit and see if you can figure out. You have a sense that we're going to be using dy, right? Because that was in the intro to this one. So see what you can do with this in terms of y. And then maybe I'll play devil's advocate a little bit and say, hey, what if I really wanted to use x? Could I do that too? But I'll let you try to figure out the y piece of it right now. The y, using dy is definitely the better way. It really is. Could be done both ways, but yeah. So we're finding the area of this region up here. How this worked and why the method that I hope you chose is the better method. And can I try to convince you of that by doing the other one? Well, please check this out. This is actually a pretty worthwhile exercise. What if someone looked at this and they said, you know what? I would like to use a vertical representative rectangle that is dx wide. This would actually be doable. It would not be the best way, in my opinion, but it would be doable. So here's what somebody could do. They could say, all right, the area equals the integral from, did you guys figure out that intersection point?
So the first intersection point is -2, or -1, -2. Sorry,
-1, -2, and this one right here would be
2, 1.
2, 1. Okay. All right. So somebody might say, hey guys, like I said, this is not the optimum way, but this is a pretty useful principle for you to see. So if somebody might say, hey, we're going to go integral from -1 to +2. So we're going to accumulate all the way over to this dashed line, and all along that part of the region, wouldn't every single representative rectangle be governed by the line on the top and the curve on the bottom? So somebody could then say, all right, so that would be x minus 1 minus, and then it would be, so gosh, it would be the square root of 3 minus x, and it'd be the negative square root of 3 minus x dx. So you'd have to do a little bit of work with this equation to get there, but you just have to solve it for y. That would get you to the dotted line, and then you'd have to add to that another integral, and it would be from 2 to the square root of 3, I guess. And it would be, I guess you could do it this way. You could go square root of 3 minus x dx doubled, right? Because don't we know that this area here is the exact same area as this area here? Yes? So you add those two up, and it should give you the exact same answers if you did it the other way. There's a pretty useful principle in like how you could find area. There's more than one way to do this. But you got to admit this is probably, compared to what you did, it's probably a lot more complex and would be less desirable. So if we get rid of all this stuff and we do what we probably should be doing, instead of doing a vertical representative rectangle, I'm going to do horizontal. And there we go. So this is still -1, -2. And this is still 2, 1. But now I'm going to go horizontal with a dy. Why is this desirable? Well, as you accumulate from bottom to top now, do you see that for every single representative rectangle you could draw in, the right side is determined by the curve and the left side by the line. That's what's so good about this. You don't have to split up your integrals. There might be times when you have to do that, like the previous question, but on this one you don't. So I'd go integral from y equals negative 2 to y equals 1. The only issue perhaps left here is we're used to doing high minus low. Whenever we go horizontal like this, what's the high? The one on the right. That's right. So the one on the right here would be the parabola. So it would be 3 minus y squared minus the line, which is on the left, quantity y plus 1 times dy. Notice that your limits of integration have to be in terms of y for this to work out nicely as well. And then we do this via pencil and paper, negative y squared minus y, so plus 2. You guys get 27.6 or 4.5? Okay. So I wanted to do this for you on paper and pencil at least one time. You definitely still need to know how to do that, right? Like I said, there will be times when you have a question like this, you're supposed to get to a finish line and actually do all the work by hand with pencil and paper instead of a calculator. It would need to look something like that. Questions, concerns, comments. Math 9 is your friend, but it's not always going to be there.
I'm just confused how I got negative 4.5 and you got 4.5. I mean, maybe I had some mathematical error.
I don't know. Did you distribute on this step? Did you distribute your minus sign to the second set of parentheses?
I'll have to double check everything.
Negative 6.
Yeah, it's because I
You got negative 6 plus 8/3. These two guys would add out, right? Negative 2 plus 2.
Yeah, that's why I crossed them out right here.
Negative, so you got negative 6 plus 8/3 minus 3 plus 1 plus 1/3 plus 1. Well, what?
That's how I could have done it clearer. It's just weird how it was like the same answer, but just negative.
I got negative 4.5 with the F's, but that's just because I flipped these.
Yeah. That makes sense. Oh, Johnny, it's not jumping out at me? Or wait, did you plug in a negative 2 or a positive 2? Negative 2. Yeah? So this should be minus 2. Man, it's...
Plus, because I first, I had first like switched these two around, but then I went back and fixed it.
Hey, I got a question for you.
God bless you guys.
So Johnny asked this question. He said, hey, I somehow got negative 4.5, yet I see up there it's 4.5. What do you do in a situation like that? Let's say it's the end of a test or something, and let's say that you get to the end, you do all this work over here or something, and you get area. Maybe you have your integral up here and blah, blah, blah. You get negative 9/2, and your mind says, wait a minute, area could never be negative. I wrote this in a really bad spot here. So you get negative 9/2. You say all that to yourself, and you're like, you know what? I only got like 30 seconds left, and I don't have time to go back and retry all this. Maybe what I did is I flipped top and bottom around. Maybe I made some simple mistake, and the answer is just the positive version of that. Can I show you what to do? Just maybe like draw arrow, therefore area equals 9/2. Something like that. That would be an okay notation. Just to correct yourself real quick. Here is the last thing you'd want to do. This would be really bad. I've seen this. I mentioned this before. This is like an automatic abuse of equal sign penalty. Those two things are not equal to each other. That would never earn the answer point. You'd never get that fixed like that. just do this. Therefore, the area equals 9/2. Something like that. So, okay. Any other questions or concerns? I'm going to look that over, Johnny, once we get started on this last one. We'll find it. I don't know what it is, yeah. All right, so then here's the final example involving area. It's right here, number 4. Calculator active, and oh my gosh, it's a piecewise. So you've got a piecewise and 2 other graphs that you want to deal with here. So use your calculator to help you get this fully graphed. Please try number 4.
Don't lie to me. Don't lie to me. Do your best and then just pray.
Is that
Don't go a bunch of towns.
What have I done?
Is that like locker
That's very college.
$2 per hour.
Diane didn't make a list of idiots?
She was an idiot, and now.
You guys okay with that graph?
Yes.
Does it look like the graph is differentiable, like the graph of the piecewise, differentiable at 0 or not? We could maybe explore that a little bit. We'll see. It's an old concept, but challenging. Not going to really affect how we do it here. Definitely a continuous graph, right? When x is 0, both of them have a y equals 2. Okay, just give you guys a few minutes to kind of wrap this one up, and then we'll check out the final answer. I want to make sure that you understand why it is best to do what we're about to do. Can anybody explain why what I'm about to write is a really bad idea? Oops. How about this?
No.
Why is dy a bad idea? A lot of different steps, right? Well, let's see here. So from here to here, it's basically red line, purple line for my boundaries. But then from there to here, it's purple line, green curve. So that would be a second integral. And then from there to here, it would be purple line, blue curve, determining my representative rectangle. So I'd have 3, not a million, just 3. So that would be a bad idea because if you do it the way that at least I noticed most of you doing it, which was from here this way, how many different integrals do you need doing it this way? Just 2. So they're both going to involve this concept to some degree. It's just that this way is going to be 2. The other way was 3, therefore making it slightly easier, somewhat easier. I don't know. Okay, so the way I'd set this up is I would say area equals the integral from whatever that is right there. And I would say probably a calculator would be a smart thing to do, finding that intersection point. What is the x value for that intersection point? Say again? 8526 to 0. And then on that particular stretch, that particular interval, it would be green curve, which is the exponential, minus the red line, which is negative x, and then dx, of course. So that would be that left little piece. And then the right larger piece, we'd just go plus the integral from 0 to 1. And that would now be blue curve, which is parabola, minus red line, which is negative x dx. Because of the 2e to the x, I don't know, you can still do this. The decimal is going to make it nasty as far as final answer goes. Probably a calculator active question. Or, AB veterans, you remember this? Remember how sometimes the question is essentially not find the area, but set up an expression involving integrals for the area? It could be something like that as well. If you're actually supposed to find the area, I think we'd probably go calculator active here and math 9 this. Did anybody do that and come up with an answer? What do you got, Brandon?
I got 102.7839. Is that?
102 point.
Oh, good.
3.617.
Were you testing us, Kennedy?
What?
Were you testing us?
Absolutely.
He just want to make sure you were awake, because it is the afternoon. And all.
Oh, I see.
What?
I don't know why, but I put my limit at 0 to 6 instead of 0 to 1.
Oh.
Sometimes that's what happens.
Well, when you have 0 to 6, I mean, that would include a lot more, like all this area out here would definitely get a lot larger.
You didn't even finish it.
So we're okay with that? All right. Okay, this will be good. So this will be a really good natural break here. But before we do this, questions, anything? You guys feeling okay with the area? Like, I guess I would say that these 3 questions would represent some pretty good examples of like the rigorousness and the challenge that you would maybe expect to see with graphing and different areas. And we've looked at 3 fairly distinctly different examples. So. All right. Well, so Jasmine asked about this, and I think this would be a really good time for this, review-wise. Let's go back and look at those. The chapter 6, that little piece. And you may or may not have that with you. If you don't, that's all right. I'll put it up on screen. And also 8, but not 7, because we did 8 after 5. I know. It's a math class. We should be going in some sort of order, but we didn't.
So the stuff that's on the Western Wednesday is like the stuff.
The nice stuff.
The mice.
Oh, mice. Yes, that would be on there. Mice minus Katie.
Reese's Puffs.
It's like Reese's
It's not Reese's Puffs.
Reese's monkeys.
It's Reese's.
Reese's monkeys.
I'm sorry, what?
Jasmine, you're talking about this one right here? Landfill?
Yeah.
Okay.
Yeah, they are.
Me. I identify.
Hey, you guys want to try this one? 6A and B. We did 6C. So, Jasmine asked about this. I don't think that 6A and B have any direct link with any test stuff, other than the fact that it's good review material. These are 2 challenging questions, so certainly can do 6A and B if you want. This is back in, yeah, towards the your little.
They don't have this anymore.
Reese's Pieces.
Things are a lot.
Most people, you have your Reese's Max and your Reese's Pieces. You either have a Mac
No,
or your Reese's. And you have a Mac or a PC. If you have a PC, it would be Reese's Pieces.
so let's see here. That would be equals 0. So W equals 300 is when the second derivative equals 0. So then we'll just do some quick calculating in our heads. When W is greater than 300. Thank you, Jordan. Have a good day. So the reason why I chose that one is because we're looking at 1411 tons, right? Bigger than 300. So when W is bigger than 300, the second derivative is positive, right? Yeah.
Right, and you know it's
And so therefore W is concave up.
okay.
Therefore we have an underestimate.
Okay.
Does that make sense?
I
Okay.
think it makes sense.
We can't. It wants it at T equals 1/4, right?
Yeah. Okay, but you don't use T equals 1/4.
I used
You just find
W's.
where W.
So so let's do it like this. We could do it the other way. We could say so T equals 1/4. Well, that's 1411, right? That's our estimate.
Yeah.
But we used T equals 0 for our. We used
For
T
the
equals 0 for our point of tangency. So you'd plug a 14. You plug a 1400 in right here,
Right.
and so you get second derivative is still positive, right?
Yeah.
So it'd be 1100 over 625, and that contains the interval with our data point as well. So it contains both the point of tangency and our point of estimation. And so for that whole interval, second derivative is positive. Therefore, W is concave up. Therefore, tangent line is below. So our estimate is too low. That make sense?
Yes.
That's an old one.
That makes
Good one.
sense.
Thank you, Jasmine.
I was a little confused, like where you got, how you could, find out where it was concave.